Hello, I am Sir Isaac Newton, a renowned physicist, mathematician and astronomer. I am best known for my work in developing the laws of motion and universal gravitation. I also made significant contributions to the field of optics and conducted experiments on light and colour.
Hi, and thanks for being here. The first question is, what inspired you to become a scientist?
Well, there were a few things that inspired me to become a scientist. Firstly, I had a natural curiosity about the world around me from a young age. I was always asking questions and seeking answers. Secondly, I was fortunate enough to have access to books and resources that allowed me to explore various scientific topics. These books opened up a whole new world of knowledge and possibilities for me. Lastly, I was inspired by the great scientists who came before me, such as Galileo and Copernicus. Their groundbreaking discoveries and contributions to our understanding of the universe motivated me to pursue a similar path. Overall, it was a combination of curiosity, access to resources, and the influence of scientific pioneers that inspired me to become a scientist.
What was your greatest challenge in developing your theories?
My greatest challenge in developing my theories. Where do I begin? Well, one of the biggest challenges I faced was the lack of available data and experimental evidence during my time. Back in the 17th century, scientific instruments were not as advanced as they are today, and conducting precise experiments was quite difficult. For example, when I was formulating my laws of motion, I needed accurate measurements of the forces acting on objects and their resulting motions. However, obtaining such measurements was a daunting task. I had to rely on crude instruments and observations, which often introduced errors and uncertainties into my calculations. Another challenge I encountered was the resistance and skepticism from the scientific community. My ideas were quite revolutionary and challenged the prevailing beliefs of the time. Many scholars were reluctant to accept my theories, and some even criticized and ridiculed them. It took years of persistence and defending my ideas through rigorous mathematical proofs and experiments to gain wider acceptance. Furthermore, communicating my ideas effectively was also a challenge. I had to develop new mathematical techniques, such as calculus, to express and analyze the concepts I was proposing. This required a great deal of effort and time, as I had to develop a whole new branch of mathematics to support my theories. Overall, developing my theories was a journey filled with obstacles and setbacks. However, I persevered through these challenges, driven by my curiosity and passion for understanding the natural world.
Now, what do you think is the most important scientific question that remains unanswered?
The most important scientific question that remains unanswered. A fascinating topic indeed. As a scientist, I must say there are numerous intriguing questions that continue to pique our curiosity. However, if I had to choose one, I would say understanding the nature of dark matter and dark energy ranks high on the list. Dark matter and dark energy are two mysterious components that make up a significant portion of our universe, yet we know very little about them. Dark matter, for instance, is believed to be an invisible substance that exerts gravitational forces, holding galaxies together. However, we have not been able to directly detect or identify it. Similarly, dark energy is thought to be responsible for the accelerated expansion of the universe, but its origin and nature remain elusive. Unraveling the secrets of dark matter and dark energy would not only revolutionize our understanding of the cosmos, but also have profound implications for fundamental physics. It could potentially lead to new theories and insights into the nature of gravity, the structure of the universe, and even the possibility of other dimensions. Of course, there are many other important scientific questions waiting to be answered, such as the origin of life, the nature of consciousness, or finding a unified theory that reconciles quantum mechanics and general relativity. But the enigma of dark matter and dark energy stands out as a captivating mystery that continues to challenge scientists and drive our quest for knowledge.
Sir Isaac, how do you think your work has impacted the world?
Well, I believe my work has had a significant impact on the world in many ways. One of the most notable contributions is my theory of universal gravitation, which revolutionized our understanding of how objects interact with each other. This theory not only explained why objects fall to the ground, but also provided a framework for understanding the motion of celestial bodies, such as planets and moons. My laws of motion, commonly known as Newton's laws, have also had a profound impact. These laws describe the relationship between an object's motion and the forces acting upon it. They have been fundamental in the development of classical mechanics and have been applied in various fields, including engineering, physics, and even space exploration. Additionally, my work in optics, particularly my experiments with light and the development of the reflecting telescope, has greatly advanced our understanding of how light behaves and how we can manipulate it. This has had practical applications in fields such as astronomy, microscopy, and telecommunications. Overall, I believe my work has laid the foundation for many scientific and technological advancements that have shaped the modern world. It has provided a framework for understanding the physical laws that govern our universe and has inspired countless scientists and engineers to further explore and expand upon my ideas.
And can you please tell us, what do you think about the future of science and technology?
As Newton, I believe that the future of science and technology is incredibly exciting. We are living in a time of rapid advancements and discoveries that are transforming the way we live and understand the world around us. In terms of science, I foresee continued progress in various fields such as physics, biology, chemistry, and astronomy. We are constantly pushing the boundaries of our knowledge and uncovering new phenomena and principles. With the development of more powerful tools and technologies, we will be able to explore even deeper into the mysteries of the universe. Technology, on the other hand, is evolving at an unprecedented pace. We are witnessing the rise of artificial intelligence, robotics, virtual reality, and many other groundbreaking innovations. These advancements have the potential to revolutionize industries, improve our quality of life, and address some of the world's most pressing challenges. However, it is important to note that with great power comes great responsibility. As we continue to make strides in science and technology, we must also consider the ethical implications and ensure that these advancements are used for the benefit of humanity. It is crucial to strike a balance between progress and the well-being of individuals and the environment. Overall, I'm optimistic about the future of science and technology. The potential for further discoveries and innovations is immense, and I believe that they will continue to shape our world in ways we can't even imagine.
If you could go back in time and do any science experiment over again, which one would it be? What has been your favorite?
As a scientist, I have conducted numerous experiments throughout my career, so it's difficult to choose just one as my favorite. However, if I had to pick, I would say that one of my most significant and fascinating experiments was the famous prism experiment. In this experiment, I used a glass prism to demonstrate that white light is composed of a spectrum of colors. By passing a beam of sunlight through the prism, I observed the light bending and separating into its constituent colors, creating a beautiful, rainbow-like spectrum. This experiment was crucial in understanding the nature of light and laid the foundation for the field of optics. It helped me develop the theory of color and paved the way for further discoveries in the field of physics. What I find particularly intriguing about this experiment is how it challenged the prevailing belief at the time that white light was indivisible. It opened up a whole new understanding of light and its properties, revolutionizing our understanding of optics and ultimately leading to advancements in fields such as photography, telecommunications, and even quantum mechanics. So, while I have conducted many experiments that have contributed to scientific knowledge, the prism experiment holds a special place in my heart due to its profound impact on our understanding of light and its properties.
One final question, Sir Isaac. In all your knowledge and your research, what is the most surprising thing you have learned about the universe?
Oh, where do I begin? The universe is full of surprises. One of the most mind-boggling things I've learned is that the majority of that universe is made up of something we can't even see or touch, called dark matter and dark energy. These mysterious substances make up about 95% of the total mass and energy in the universe. It's fascinating to think that there's so much out there that we still don't fully understand. Another surprising discovery is the concept of black holes. These are incredibly dense objects formed from the remnants of massive stars that have collapsed under their own gravity. They have such strong gravitational pull that not even light can escape from them. Wrap your head around that. It's like a cosmic vacuum cleaner that sucks in everything around it. And let's not forget about the expanding universe. Back in the day, it was commonly believed that the universe was static and unchanging. But thanks to the work of astronomers like Edwin Hubble, we now know that the universe is actually expanding, Galaxies are moving away from each other, and the farther away they are, the faster they're moving. This discovery opened up a whole new field of study called cosmology, which explores the origins and evolution of the universe. These are just a few examples, but the universe is full of surprises waiting to be uncovered. It's a constant reminder that there's so much more to learn and explore.
Thank you, Sir Isaac Newton, for your time and insights. It was an honor to speak with you. And if you enjoyed this episode, please subscribe to Academia AI Podcast, leave a review, and share it with your friends. That will help us to create more episodes with more amazing historical figures. See you in the next one.